Hello, this is going to be my video on the different number of solutions when you have a systems of equations. So that's when you've got multiple lines. So if you have one line, we talked about before how any point that's on the line is a solution. And any point that's not on the line, those are not solutions. That's what we talked about last video. And you can think about it in any number of terms. But right now, we're going to look at when we have two lines and different situations. So this first situation, we've got one solution. This is going to be the majority of your situations. That one solution is going to be 1 point, so you're going to have an x and a y. So if I had a general graph, and then I had two lines, hey, I'm a red line, and I'm a blue line, we're crossing. We're crossing at this point, x, y. I'm going to go ahead and randomly approximate it based on these dots, and say it's -4, 3. 4 to the left, 3 up. That's a solution, one solution situation. There are not any other points that hit both of these lines. There are points that land on one of the lines, but not on both. So only that crossing point, that intersection, is your one solution. And any two lines, even if they are super small slope, and you're like, oh my god, are these lines ever going to cross? Well, yeah. No, even if it's a really small slope, eventually they're going to cross. So anytime two lines have different slopes, two lines with different slopes will always have one solution. Boom. So that's going to be the majority of your situations, but let's not get lulled to sleep by that. We also might have no solutions. So go ahead and just pause and think. When could you have two lines that never have an intersecting point, that never touch? Okay, so hopefully someone at your table held up two fingers, or it was like, hey, look at those lines, they would never touch, and they are going to be lines that have the same slope. So if two lines have the same slope, but they start at different points, they're going to have no solution. They're never going to touch. They have to have the same slope though, or else, like before, if they have just slightly different slopes, eventually they will touch. You all also heard these called, what someone has probably already said, is parallel lines. And some people, when they're looking at that double L and parallel, they're like, hey, those are parallel lines. They have the same slope. Numerically, this is like, you got your slope equals 3, and your other slope is also 3. Even if you have a slope of 3 and a slope of 2.9, these are close, but not the same. They're not parallel. They would be over there. So it's got to have the same number, or look exactly the same slope, but starting in different places to be parallel lines and have no solution. So the last situation you might see is infinite solutions. So how could we have an unlimited amount of numbers of places where two lines are touching? So go ahead and pause and think again. So the only way for this to happen, and I'm going to bust out the tie-dye lines for this, boom, is if we had two of the exact same line. So I don't know how I'm going to do that. I'm going to try to draw them on top of each other, but just so you know, this is two of the same line. So if I have two of the same line, every point on those two lines is touching. So that means there's an unlimited number of solutions. Unlimited, good spelling. From a numericals perspective, you might see this as if I had 2x plus 3 and then I had another 2x plus 3. Or they might try to trick you and like double everything and say, hey, one of these lines is 2y equals 4x plus 6. But still, these are the same. So if you have two lines that are the same, you're going to get infinite number of solutions. If you have two lines that have the same slope, never touch, parallel, no solution. But most of the time we're going to see two lines, whenever they have different slopes, they're always going to crash at some point and create one solution. One last point of note, for my infinite solutions, that is when we have the same slope. So it's just like the no solutions one, but it's also when we start at the same point, when we have the same intercept, y, intercept, or x, but same deal. So That's the progression and kind of a baseline. So play around with it, figure out, look at those different situations where you're going to have 0, 1, or no solutions. 0, 1, or infinite solutions. Yeah. Okay, bye.